Okay, perfect. Okay, let me know. Can you guys see my screen right now? Yep, perfect. Okay, so this one is similar to question number 1, where they give you a graph and they want you to write the equation either in the form of the sine or the cos graph. So you want to show all your work as well. So this one is similar to question 1. So what you want to do is you want to start by finding each of these letters. So A, B, C, and D. Okay, I always leave C to the end because that is the only thing that is different between sine and cos. So that's the only actual real difference between them, is there's like a phase shift that takes you from cos to sine. So that's it. Okay, so what you're going to do is write A equals. All you have to do to find A is your amplitude. So that is always found by taking your max minus your minimum and dividing by 2. So then you look at your max height. We know that our max is 3. So we're always looking at the y coordinates when we're talking about amplitude here. So its max is 3. Your minimum is -1. So you'd subtract -1, and then you divide that value by 2. So that's going to be 3 plus 1 divided by 2, which is 2. So that's your amplitude right there. That's going to be the same for either the sine graph or the cos graph. So that's how you find your amplitude. Then we have our b value. Our b value is found by taking 2 pi and dividing it by your period. Now, the reason I'm using 2 pi is if you guys look, your x values are in radians. If you saw a degree symbol, you would use 360 instead. You would go 360 degrees and divide it by your period. So I'll show you how to find your period. So what you do is, if you guys look, I'm going to start at the y-intercept value. Okay, so what you're going to do is you're going to go all the way up to include a maximum, and then it's going to come back to, in this case, the minimum. So that's one cycle. So the period is how long does it take to complete one cycle, where if you were to cut this and glue it on the other ones, it would look exactly the same. Okay, so this is one cycle going one rotation around this circle. So they're asking how long does it take to go around the circle? Well, this circle is actually a distance of pi. So I would go 2 pi divided by the period, which in my case is pi as well. And then you would just cross these off because those would simplify to give you the b value as 2. So that's how you find your b value. So 2 pi divided by your period. So you're just going to have to figure out what your period is. So what is one rotation around your circle? And then I'm going to leave D for now, or I'm going to leave C for now. I'm going to go and skip to D because that one is also the same for both the sine and the cos graph. So your D is found by taking your max, added with your min, and then divided by 2. So this is actually another name for your midline. This is the line that cuts your graph straight in the middle and cuts it in half horizontally. So your max is 3. Plus your min is -1, and then you're dividing that value by 2. So 3 minus 1 is 2, divided by 2 is 1. And you can check to see if this makes sense, because if you guys look along y equals 1, and if I were to make a dotted line along y equals 1, you would see that that line cuts it directly in the middle, where you have the same distance above and the same distance below. Okay, and then if you were to count the blocks above and the blocks below, this distance here is actually your amplitude. So if you guys look, there's the distance is 2 above and 2 below, and that's what your actual amplitude stands for. Okay, so this is my midline. And the last one is your C value. So that's the one you kind of have to think about and figure out which graph would be better for this, okay? So I always find that cos is easier to find your C value for. So I'll do it as if it was cos first. So cos, you want to look for the closest maximum. Okay, so as you can see, guys, I have two maximums. They're actually at the same distance. There's a maximum and there's a maximum. They're actually equally spaced away from your y-axis, so it really doesn't matter which one you use. So for example, let's say I chose this one. Let's say that one was the closest one. What I would do is I would say that, well, I know that normally my maximum for cos is supposed to be on the y-axis, but it's moved to this location. So there's been a phase shift of pi over 2 units to the right. And so all you would do is that your C value would then be, in this case, pi over 2. Okay, so pi over 2 would be your phase shift in this case right there. So that's for cos. The closest maximum is what you use to find your C value when it's cos. Then you want to look at sine. Sine is a little trickier. So remember how I said that the 1 was that midline. So I'm going to trace out that midline again. So you want to find the closest point where the graph is at the midline. So this point right here, do you guys see how that is on the actual midline? And it should always be going up from that midline. So I can't use this point. This point cannot be used because if you guys look, it's going down from that midline. So that is not an accurate one. You want to choose where you're at the midline and going up. So this is what should have been on the y-axis. So it moved from the y-axis to this location right here. And if you guys look, well, what is 1 block equal to? Well, 1 block is equal to pi over 4 because it's the same as taking this value and dividing it by 2. So 1 block is pi over 4. So I know that for sine, we actually moved pi over 4 units to the right. Okay, so that's how you do sine and cos. So cos is the maximum, closest maximum, and sine is the closest kind of midpoint value where it goes up from there. You're just figuring out how far did it move away from the y-axis. So that's the most complicated part, I find, when you're trying to describe the equations. So the last part is just writing it as an equation now. So your final step is to now fill in all these values into the actual equation. So A is 2. And then let's say I was doing cos. I would go cos. Then I would put my B value as 2. X minus your C. So this is the cos one. And then plus your D. So that would be how you can describe the cos graph. And if you were to graph this, it would look identical to what the graph would look like. So that would be your way of checking to see if you did this properly. And then let's say you were doing sine. Sine would be the same A value. Oops. The same A value, the same B value, but your C value will just be then pi over 4 instead to the right. And your D value will also be the same. Okay, so that's the only difference between the sine graph versus the cos graph. So you should see a difference between the C values. Now, they were just saying, in your question on your assignment, they just want you to pick one of these and then the one that best describes it or the one that's easiest to describe it. So you pick the one that you want to choose, either that one or that one, okay? So you pick between sine or cos to describe your graph and then check your answer by graphing this in radian mode and seeing if it looks like the picture that you have. So that's how you know you did this properly. And this is how you show your work. Show all these little steps here to get your answer. Okay, so that's question 1 in your assignment. Thumbs up. You guys good so far? Wilfred's good. Perfect. Liam's good. Sarah's good. Perfect. Okay, so the next one is sketching the tan graph. So I've chosen to change it slightly. I changed it where the period's going to change slightly to, you'll see that the period is actually going to be 2 in this case. Well, slightly different. This one, it's going to be, it's just going to be double the period. So it'll be wider. Okay, so I'm going to graph 10 1/2 x in this case. So in this question, they do want you to change your mode to radians mode. So make sure that you change the mode depending on the question. So mode, make sure you've highlighted, in this case, degrees, and then change your window. So I'm going to go from negative 360 for my question up to positive 360. And then my scale for 10, I usually choose about -5 to +5 is usually adequate for when we're talking about the tan value. Well, my scale should be 1 there. So I'll go up by 30 degrees if I want to for my scale for x, and then my minimum will be -5, my maximum will be +5, and my y scale will be 1, okay? So use the scale or use the domain that they're giving you in the actual question. When you graph it, you're going to see something like this. All they want you to do is sketch what you have, but do that accurately. So what you do want to do is kind of look for key points. For example, you want to mark off where the x-intercepts are. And then you also want to mark off where these vertical asymptotes are. So these lines right here, guys, these vertical lines are actually asymptote lines that are shown. Okay, so they're not really part of the graph. Depending on your version of calculator, some of your calculators will show that vertical asymptote, some of them might not. So mine actually does show it, and that's, I can't really click on it because it's not even part of the graph, but this is that line I'm talking about, this straight line. Okay, so there's vertical asymptotes. And then as you can see, mine goes through 0, 0, so I would mark that off. And then I would also mark off where my vertical asymptotes are. Remember, my scale is 30 degrees, and that can help you a lot to find out what your values are without actually calculating them. So I know that I have 30, 60, 90. I know that my vertical asymptote in my case is at 180 degrees. So it's at positive 180 degrees and negative 180 degrees. So I can use the same scale here, 30, 60, 90. And we have 120, 150, and 180. Okay, so I would mark off those. So those would be important things to label on your graph, is those vertical asymptotes. And do the same for the other side as well. Okay, so the other parts aren't bad. Like, the other parts aren't bad because as long as you go through your x-axis and stay close to those vertical asymptotes, then it's not much to sketch it. Okay, and just include arrows on each end because it does continue forever upwards and downwards. And then mine is just gonna, I can't really see that x-intercept. It looks like it's at, sorry guys, it looks like it's at negative 360 for me and positive 360 for me. So let's say this was at 360, negative 360. I know that that's where it's going to touch the x-axis. And again, I would show arrows. And over here, it's going to go through the positive 360 kind of line. Okay, so whatever you can see, whatever your domain is, use that to represent your graph. Okay, so that's all they wanted you to do for question number 2A. The next part is they want you to actually sketch a vertical or a horizontal line at the square root. For you guys, it's going to be the square root of 3. Mine is square root of 2. So I know that's approximately at 1.4. So I'm going to take maybe a pink line and sketch 1.4. Okay, so that's what you would actually sketch on the graph, but they do want you to find the points where it intersects. So the list the points where the two functions intersect. So that's where you're going to go back to your graphing calculator and put that for y2. So I'm going to include square root of 2 in my case And I'm going to graph that. And wherever you see an intersection, you're going to find those intersections by going second trace, number 5. Move as close as you can to the intersection, and you're going to have to press it 3 times versus mine is only twice for some reason. It's not working for some reason. Okay, so I did this with my regular calculator and it will work. Like I said, this is what happens with apps. Okay, so all you're doing is finding the intersection. I'm just going to do it on my own regular calculator because that one's not worked, just to show you my answers. Bear with me for a second. So, well, actually, you know what? I know what I can use. My backup is always Desmos. Okay, so you can use Desmos, of course, too, guys. If you struggle, like if your calculator is not helping, you can always double check your answer using Desmos, which is what's nice about all this stuff here. No, I don't want that there. Okay. So with my graph, remember you do have to be from negative 360 to positive 360. So you're going to have to change your mode, which you can actually do here. You can actually change to radian mode, and then you can go actually in degree mode. So you can change from degree mode to radian mode or vice versa. And then you can change your X axis to go from negative 360 to positive 360. So you can change that with Desmos as well, which is nice. Okay, so once I have that changed to degree mode, all I'm doing is I'm finding the intersection. And if I click on here, it tells me that one of them is going to be at negative 250. So you can include some decimal values right there. I hope you guys can see that. I'll zoom in a little bit more. So there's one intersection right there. For me, I have a second intersection. I have a second intersection right here, and then I have a third intersection. Oh, actually, let me see if mine shows that. So when I graph it, yeah, so in my case, I only have 2 intersections that I'm solving for. Don't include those. You can't include the vertical asymptote. So I only have these 2 guys, that one and that one, to actually locate. So you're just looking for the intersections, include them as coordinates, and that's it for question 2B. Any questions about that one before I go on? I don't find that one, I don't think that one's overly difficult. It's just about being able to sketch the tan graph. You guys good so far? Good. Sarah saying good. How are you guys doing? Liam, Wilfred? Liam's good. Wilfred, you still alive? Perfect. Okay, question number 3. So question number 3, this one is giving you the equation, but I'm going to have to graph this anyway. You guys are given an equation and you're going to have to interpret the information from that picture. Okay, so I'll start by graphing mine here. So I'll just do that on my graphing calculator here because, like I said, it's not the best, the other one. So this one, you're going to have to be, in my case, I'm going to have to be in radian mode whenever I see that pi symbol. Okay, now, whenever you're graphing something, just as a hint, if you're trying to figure out what your domain should be or what your range should be, you're going to have to answer this question anyway, so it helps to do this. Find your period, which they're going to ask you that question anyway in the question, like they need to know that. So the period can always be found by taking 2 pi and dividing it by your b value. So just switching those spots, because last time it was 2 pi divided by your period will find you your b value. So this one's just reversing the spots. Now, the value in front of your x value, or in this case t, is my b. So you're going to go 2 pi divided by pi over 45 in my question. So 2 pi, you're going to multiply by the reciprocal of the second fraction, which is then 45 over pi. These guys are going to cross each other off, leaving you with 2 times 45, which is 90. So we know that it's going to take 90 seconds for this, in my case, a Ferris wheel to go around 1 time around. So that's going to answer this question C. Determine the time required for the Ferris wheel to complete 1 revolution. So you'd say 90 seconds. So however long it takes something to return to its original position will be your period. So that's what you can use to describe. In your case, I think it's like a pendulum, right? So use that. You just want to explain that in words. Okay, so however long it takes to go back to its starting position is your period time. And then your maximum can always be found by taking your d value. So this is your midline value. So this is my d value. I'm going to try to write on this. There you go. D and A. If you take your D and add your A, that will actually give you your maximum value. So if I take 15 and add 12, that's going to give you 27. Now for you guys on your graph, you can actually look at your graph and find out what the maximum is. So that's a little bit easier, but you just want to then state that in my case, the Ferris wheel will reach a maximum height of 27 meters. Okay. And so for you, your maximum will just represent the highest height that is reached. And then we have our minimum, which is where you're taking your midline and subtracting your amplitude. Okay, so you're going to take your 15 value and subtract 12. And for me, it's going to be 3 meters. Okay. Now you can always check this. So what you guys are doing is I'm describing what these would mean in your pendulum. What do you think they represent? So it's more like an opinion too. So it's like, what do you think that these values represent on the pendulum? Okay. What else did I want to say? Oh, there's something else I was going to say about that. Oh, the amplitude is another name for radius. That's another hint for you guys. For your question 3, your amplitude is actually always equal to the radius of the circle. So the radius of your situation, that's what it's actually equal to as well. So my radius is actually equal to 12. And then your D value, which is your midline, is actually your average. So this is like your average height that is reached by the graph. Okay, so that's another kind of hint when describing the characteristics of your graph. So when you're talking about those, use those words and that will kind of guarantee you good marks. Hint, hint, okay? So your amplitude in this one was 12 and your midline in this case was 15, and then include units if they give those units for you guys as well. Okay, so we're going to sketch this right now. We know that every 90 seconds it's going to repeat itself. And since time cannot be negative, I'm not going to include any part of the graph in these sections here. So I'm going to go up by 45 seconds. So I'll have, actually, no, I do want to go more. Let's try. I'm trying to figure out a nice kind of scale. 1, 2, 3, 4, 5. Yeah, okay. I'll go up by 18 seconds because that will get me to 90. So 18, 36, 54. Oops. 72, 90. Okay, so that would be one cycle of this, this kind of picture. So I'm just doing the graph of it because that's what this question was requiring. Yours already gives you the graph, which is nice. They also give you the max height of 27 and the minimum at 3. So we do want to include those values. So I'm going to go up by 3. 3, 6, 9, 12, 15, 18, 21, 24, and then 27. Okay, so since we're graphing the sine graph, we do know that there is a phase shift of negative 30 degrees. So our midline should actually start at 30 degrees to the right, or 30 seconds to the right. So at approximately 30, you should be at the height of 15. So that, remember, is your midline. And then from there, it goes to the right and reaches your maximum. So of course, sketch this if you want a better picture of this. Put this into your graphing calculator and get some values for this. So go to your table of values and then plot some points. I'm just kind of looking at the characteristics here. X minus 30, I'm just putting this into my graphing calculator. Change your window to look like what you have, and then go to your second graph and look at the table of values and plot some points. So I'm going from 0 to 90 for now. And my minimum height is going from 0 to 27. I'll go up to 28. So like I said, I'm going to second graph. If you were to sketch any kind of graph, you can always use your table of values. So I know that when x equals 0, I know that the value is about 4.6. And I know that at about 8, when x equals 8, it's going to reach the value of 3. Now I do want to go up to the maximum, so I'm going to keep going until I get to the maximum value. So I know that it reaches the maximum approximately at, let's see, probably about like 58 point something. Oh, it should be actually a little bit better. Okay. So once you have this sketch, they also want you to determine the height of the rider above the ground after 45 seconds. So this is where you can either put t as 45 seconds. So you can replace t with 45 seconds, put that into your calculator and calculate it, or with your graphing calculator, you can always press trace 45, enter. So when I do that, I know that my y height is going to be about 25.39 meters above the ground. Okay, so I'm just checking if I answered all the questions so far. I have the max and the min. I have the time required for the Ferris wheel to complete 1 revolution. And then I made up question E to show you how to do this for your assignment. So for this one, it says, how many times does a Ferris wheel go around in 3 minutes and 45 seconds? So how many revolutions does it make around the circle? Well, this is where you're going to use the period. Our period is 90 seconds. That's how long it takes to make 1 revolution around the circle. So you need to convert this all to seconds first. So I'm going to start by taking 3 minutes and multiplying it by 60, and then adding 45 to that. So that's going to be equal to 225 seconds. Okay, and then all you're doing is you're dividing it by 90. And that tells you, oh, is that what I wanted to do? Give me a sec. Oh yeah, that's fine. So then I'm dividing it by 90, and that tells me that it's going to be about 2.5 revolutions. Okay. So in 3 minutes and 45 seconds, I can make about 2.5 revolutions. Okay. So that's what you can do to find out question E in this case. Okay, so like I said, for this question number 3, when you're talking about when you find your amplitude, when you find your midline, when you find your phase shift, when you find your, what else was it? Your period, use those and just describe what they represent in terms of a pendulum, what you think they represent in terms of a pendulum. For amplitude, use the words like radius. For the midline, use the words like the average. And then for the phase shift, that just means like that your average is starting at a certain value. So your average for sine is starting at, in this case, 30 seconds. Okay. Any questions about that one? So that one's a little one where you kind of have to relate what you've learned to like a real life aspect. Any questions? How are we doing, guys? Good? Okay, perfect. Okay, so your last question just wants you to, they want you to be able to solve this both algebraically and graphically. Would you need to do a dull circle for, no, you wouldn't have to, like you're saying to, oh, would you need to draw? Would you need to do a full circle for pendulum? Like for one swing? Well, one swing is a full circle around the circle, like is a full rotation. So one full swing, when it goes forward and back and returns to its starting position, that is an actual full rotation when you look at it, because it goes to its maximum height and then goes back to its minimum height, right? So that it is a full circle. Would you need to do a full circle for pendulum? Yes, it is a full circle. Okay. And then example number 4, determine the solution. So I'm going to show you how to do this algebraically, and then the graphing one is just putting into your graphing calculator. And then whenever an equation is equal to 0, you're pretty much solving for the x-intercept. So I'll zoom into this one so you guys can see the question that I'm solving for. And I changed it, instead of it being in the interval of degrees, I changed it similar to yours where it's in radian mode, okay? So algebraically, you're just going to solve for cos of x by isolating for it. So you're going to bring the 1 to the other side. That's going to become positive 1. And then you're going to divide by 2 on both sides, leaving you with cos squared x equals 1/2. Now you're going to square root both sides. And what's important for these questions is that you have positive, negative for the answer. Okay, so you need to include the positive, negative. Square root of 1 is 1. And then square root of 2, you need to leave it as square root of 2 for now. Okay, you can always rationalize it, but it's not really crucial for finding your answer. So you can leave it like this. So we need to find out x, where positive or negative is equal to 1 over square root of 2. So what I like to do for these, this is like kind of my like cheating method, is I really like to personally work in degrees and then just convert it, okay? So what I'll do is in my calculator, I always like to change it to degree mode. So of course you can look at the unit circle and try to figure out where this is, but I am changing it to degree mode, and then I'm going to do x is equal to cos inverse of 1 over square root of 2. So you're going to have to do cos inverse of 1 over square root of 2 in your calculator. Now, if you're doing these properly, because if they ever want exact answers, you should be getting one of those special triangle angles like 45, 60, 45, 60, or 90 degrees or 30 degrees, right? So if you're getting those, you're probably on the right track. I got 45 degrees, which I know is equal to pi over 4. So that's kind of what I do, is I find the angle in degrees and then I just convert it into radians, and then I work in radians from there on, okay? Because once I know the reference angle, so this is your reference angle, I find it makes it really easy to do the rest, okay? Now, what's different about these kind of questions is that there's going to be an answer in every quadrant. because your answer could be both positive or negative. So you're going to have an answer everywhere, okay? So first of all, in quadrant number 1, the answer is going to be pi over 4 because the reference angle is your rotation angle in quadrant 1. And then in quadrant number 2, you're going to have to go 180, which is pi, and you're going to have to subtract pi over 4, the reference angle, to get that rotation angle. Then we have quadrant number 3. You're going to have to go pi plus the reference angle, which is pi over 4. And then your last one in quadrant number 4, you're going to have to go 2 pi, which is 360 degrees, and subtracting pi over 4. Okay, so once you do the math, those are your solutions for this kind of question algebraically done. Okay, so for the first one, we already know that that's the answer. But then for this one, I'm going to get common denominators and subtract pi over 4 to it. So that gives me 3 pi over 4. And then here, same denominators. 4 plus pi. 4 pi plus pi is equal to 5 pi over 4. And then finally, your last one, you're going 8 pi over 4. That's how you get common denominators with fractions. And then 8 pi minus pi is 7 pi over 4. Okay. So once you have these answers, what I like to do now, because it doesn't tell me that I want exact answers, but I just think it's better. It's always better if you can. So I'm going to leave those answers. Those are going to be my actual answers. But because I'm going to do this now graphically, and to compare my answer, I'm going to convert these to decimal form. So I'm going to go pi divided by 4 in my calculator, and I know it's approximately equal to, this is how I'm going to check to see if I'm doing this properly. I'm going to get 0.785 approximately. Then I'm going to do that for each one. My next one, 3 pi divided by 4 is approximately equal to, I'm just going to write the answers here actually. It's going to be approximately equal to 2.356. Then I'm going to do 5 pi divided by 4, 3.927 when I round. And the last one, 7 pi divided by 4, 5.498. So these are the answers I should be getting when I do this graphically. If I get these answers graphically, then I know that I did the first part algebraically done right. Okay. So now I'm going to go to my graphing calculator, and you're going to graph 2 cos squared x minus 1. So I'll show you how to put that into your calculator. So 2 cos x, and then outside of that, you're going to square it. Okay, so you're actually going to have to, because it's just how we write it. The little 2 goes between the cos and the x, but we can't do that in our graphing calculator, so the cos has to go outside of cos x. And then I think it was minus 1, yeah. Subtract 1, and then you're going to change your window. So I'm going to go from 0 to 2 pi, going up by, we know that that's going to be, we can use the scale that we have, which is pi over 4. So we can go second shift. So shift or second with that little exponent symbol, you'll get the pi. So pi over 4 is what I'm using for my scale. My y min and y max, I can keep them the same for now and then adjust them if I have to. So this is what I'm keeping for my scale, because all I need is my x-intercepts. If you solve for your x-intercepts for my case, then that is the answer. So as long as you can see the x-axis, that's all we need. And for mode, I'm going to go back to radians mode. Now I'm going to graph it, and as you can see, I have 1, 2, 3, 4 x-intercepts. So you just need to find your x-intercept by going second trace number 2. Go to the left side of it, press enter, right side of it, press enter, and then as you can see, it's 0.785. That was our first answer. Check mark, done. Okay, and so you would do that for each of the following x-intercepts, confirm that that is properly done, and then you would just describe what you did. So to get full marks, you're just saying y1, I put 2 cos squared x minus 1. The window that I used was 0 to 2 pi, going up by pi over 4. And then that was my x window. My y window was -5 to 5, going up by 1. And then just describe your steps. And then say that I pressed second, trace number 2, and I found each of the x-intercepts, and these were my x-intercepts that I found. Done. Okay, and then you can say, therefore, the solutions match algebraically. So I have checked. And that is how you finish off. Okay, so as you can see, you should get all these 4 values if you did it with your graphing calculator. So any questions about what I did so far? So the only one that should be a little bit of thinking is the pendulum one. The rest of them are pretty straightforward. So it's just the pendulum one that you have to figure out how that looks or what those values mean in terms of the pendulum. Okay. How are you guys doing? Good so far? Good? So that was it. That's all I had to do. So there was not much I found that's crucially important for this section 5.1 to 5.4. So as long as you kind of get this idea, that's like the main thing, is just being able to graph them and find your amplitude, your midline, your period, and your phase shift. Okay. Any other questions, guys? If you need help with your past assignment, if you need help with Trig 1, just let me know if you have any specific questions for that. Otherwise, get this assignment done, hand it in, and then you have 2 left after this, and then we're home free. Okay. Liam, Wilfred, you guys are good? Sounds good. Thanks, Liam. Thanks, Wilfred.